So we're here at the example table, and in this video we're going to look at the derivatives of sine and cosine. So just to remind ourselves what those are, the derivative of sine of x is cosine of x, and the derivative of cosine of x is not quite sine, but almost. It's negative sine of x. So we can use these actually to derive the formula for the derivative of tangent. And let's do that in our first example. So let's say that f of x is tangent of x. The reason we can use sine and cosine is that tangent of x is sine of x over cosine of x. So with the quotient rule and with these two identities, we have everything we need. So f prime of x, quotient rule says that f prime of x is the derivative of the numerator times the denominator. So we start with the derivative of sine x. I'm going to write this out in two steps, so I'm going to write derivative of sine x before I write cosine x. Since we have all these sines and cosines floating around, this will make it a little less confusing. So derivative of sine x times cosine x. Next part of the quotient rule, subtract the numerator times the derivative of the denominator. So we have minus sine x times the derivative of cosine x. And this entire thing divided by the denominator squared. So cosine squared x. So what's the derivative of sine? Well, it's cosine. So this is cosine squared x. Right? Cosine times cosine gives us cosine squared. Now minus sine times the derivative of cosine. Well, what's the derivative of cosine? It's negative sine. So minus sine x times negative sine x all over cosine squared x. Now you might already see where this is going. This minus and this minus cancel, and on the top we end up with a cosine squared plus sine squared. So let's do that on the next sheet of paper. So continuing, this is equal to cosine squared x plus sine squared x all over cosine squared x. Well, what is this? Usually we write it as sine squared plus cosine squared, but whichever order we see it in, this numerator is just 1. So this is 1 over cosine squared x, and we can write that as secant squared of x. So this is a common theme in just about anything you do with trig functions. There ends up being a lot of simplification, a lot of trig identities that you can use, and this is no exception. But that's how you can derive the formula for the derivative of tangent using the derivatives of sine and cosine. Let's look at another example. Now let's derive the formula for the derivative of secant. Now secant is 1 over cosine x. So once again we could use the quotient rule where our numerator is 1 and denominator is cosine. In this example I think I'd rather use the power rule and the chain rule just to vary things a little bit. So 1 over cosine is the same as cosine x to the negative 1. All right? Now we're going to be able to use the power rule and the chain rule. So f prime of x is negative 1 times cosine x to the negative 2. That's the power rule. And then since we have a function inside here, a function inside this something to the negative 1. We need to apply the chain rule. So we multiply this by the derivative of what's inside. And the derivative of cosine is negative sine x. So let's rewrite this a little bit. We have a negative times a negative, so that disappears. And let's move this entire cosine term into the denominator. So on the top we end up with sine x, and the denominator becomes cosine squared x. Well, I'm going to split this cosine up. So this is the same as 1 over cosine x times sine x over cosine x. This first part is secant. And the second part, we can remember from the first example, is tangent. So there's our derivative of secant x. Once again, using only the derivative, in this case, of cosine. Let's do one more example. Suppose f of x is sine squared x minus cosine x. Then f prime of x is what? Well, the derivative of this one, we're going to first use the power rule. So a 2 comes down, and then we have sine x to the first power, so I won't write any 1. And then by the chain rule, we have to multiply by the derivative of sine, which is cosine. So that's the derivative of sine squared x. Then minus the derivative of cosine, which is negative sine. So we have minus negative sine x. And this we can rewrite as 2 sine x cosine x plus sine x. And those are some examples of derivatives with sine and cosine.